Hello everyone. My name is Min, and today I'm gonna show you the animation about special theory of relativity. In 1905, at the age of only 26, Einstein published his special theory of relativity, which revolutionized physics field. He based his theory on two postulates. The first one is all the laws of physics, those dealing mechanics, electricity and magnetism, optics, thermodynamics, and so on, must be the same in all inertial reference frames, also called principle of Galilean relativity. The other is constancy of the speed of light always has the same value, is 310 to the 8 meter per second. Einstein devised the following thought experiment to illustrate this point. There are two observers in this case. Observer pink is on a boxcar moving with uniform speed, and observer blue standing beside. Suddenly, two bolts of lightning strike the front and the back of the boxcar. Obviously, the light signals reach observer blue at the same time. Blue realizes that the signals traveled at the same speed over equal distances and so concludes that the events occurred simultaneously. Meanwhile, pink is moving, so it's a little difference. Based on the second postulate, the light must travel at the same speed. As you can see, the distance between the front bolt and observer pink smaller than from the backside. Apply the formula time equal distance over velocity of light, we compute the time which the signal reach from the front must be shorter. In other words, observer pink sees the signal from the front before seeing the signal from the back. So she concludes the front bolt is faster. Two observers' viewpoint are different, but both are true, which lead to the first conclusion of Einstein's theory. Events that are measured to be simultaneous for one observer are not necessarily measured to be simultaneous for another observer who is in motion relative to the first. Let's move to the next experiment. In the boxcar, pink has a flashlight to the mirror with a distance d above. At some instant, the flashlight emits a pulse of light directed toward the mirror, and at some later time after reflecting from the mirror, the pulse arrives back at the flashlight. And she compute the time is equal to 2d over c. At the same time, blue is also standing beside, and her detection is different. Blue concludes that because of the motion of the vehicle, if the light is to hit the mirror, it must leave the flashlight at an angle with respect to the vertical direction. And she compute the value of time duration is 2d over all c square root of 1 minus v square over c square. Compare with pink's number. We can see that blue's time is equals to gamma multiply with pink's time. Gamma is always greater than 1, which means blue's time is longer than pink. That's why Einstein have got his second consequences. The time interval measured by an observer moving with respect to a clock is longer than the time interval measured by an observer at rest with respect to the clock. This effect is known as the time dilation. Here comes to the last experiment. Assuming pink is using spacecraft to travel from the Earth to the Saturn. We've had the velocity v and the distance l. Blue is sitting on the Earth, compute the distance l is equals to vt. The same as pink formula. But according to time dilation, the time measured by two observers are separated, are different. We will get that the distance in blue measurement is also equal to pink's distance multiply with gamma. Obviously, blue's length is also longer than pink. The lengths of objects in motion are measured to be shorter in the direction of motion. This effect called length contraction. In short, with two postulates, Einstein mentioned three things about the special theory of relativity. It is the events measured by the first person may differ from those measured by the second, if they are moving relative to each other. The time dilation and the length contraction. All the animation sources are from the Physics for Scientists and Engineers written by Serway Jewett. Thank you for watching.